In this video, we'll break down Docker volumes, when to use bind mounts, and when to use named volumes. And if you stick around to the end of the video, I'll show you even a third option. So let's start with the core problem. Every Docker container has something called a writable layer. Think of a container like this: the base image, which is read-only, and then a thin writable layer on top. Any changes you make, logs, files, installs, anything, goes into the writable layer. Now here's the catch. When you remove the container, that writable layer is deleted. So without volumes or bind mounts, your data is gone. This is because containers are designed to be ephemeral. So to persist data, you need to store it outside the container. Docker gives you two main options: bind mounts and named volumes. A bind mount connects a folder on your host machine directly into the container. I'll show you an example right now. Let's see. So I'm gonna run a nginx container, and I'm gonna mount in configuration, and I'm gonna mount in HTML, which is just a simple static HTML blog file that I vibe coded with Stitch. To run this, we're gonna run docker run rm it. I'm just gonna run it interactively, and we will just delete it afterwards. I'm gonna mount the current directory config into /etc/nginx/conf.d, and then we're gonna make another bind mount for HTML into user share nginx HTML. And then we're just gonna bind the port 8080 from the container to the host. And then we're specifying that we're using nginx 1.29 alpine image. So before we run this, I also just want to show you the configuration. So this is the default configuration from nginx. I just changed the listen from 80 to 8080 because why not? Just want to show you an example of what you can do with configuration files that you work on with bind mounts and HTML files. So let's run this one. Again, it's docker run --rm -it -v and the config path, -v and the HTML path, -p ports, and the Docker image. So now it's up and running. So if we find our browser, which is right here, and then we go to localhost 8080, we'll see that our static HTML blog is served through nginx right here on port 8080. So that's just a very, very simple way of binding data into Docker. I'm just going to show you something else that we can do. If you go back to the terminal right here, and you can see that I cancel this and have this Docker compose file, which does exactly the same thing. Takes relative path config and relative path HTML directories, mount them into the path I specified. What we also can do, we can specify the flags at the end, read only or read write. So we mount the configuration as read only inside the Docker image and the HTML as read write. So when we now run docker compose up -d to run it in the background, and we just take a look at our browser and we reload the blog, and we see that it's up and running. And we can do the exact same thing through a docker compose file, which I wrote here. And then we can also specify the flags for the mount, which in the first case we mounted as read only, and in the second volume mount here, or bind mount, excuse me, we're mounting it as read write. So you would typically do read only for configuration files and read write if you have a development environment that needs hot reloads, etc. So you have more fine-grained control over which bind mounts the container can write to. So if you just run docker compose up -d, and then we go back to our browser again, we can see that our blog is still up and running, and that's pretty good. So this means that you control exactly where the data lives. Docker doesn't manage it. It's just in your local file system. Think of it like plugging your own hard drive into the container. You want to use a bind mount when you have a local development environment, when you have live code editing or debugging the application, because any changes you make on your local machine instantly reflects inside the container. Okay, so let's move over to named volumes. Named volumes are managed by Docker. What happens when you run with a named volume is that Docker creates the volume, Docker stores it on the host, and Docker mounts it into the container. On Linux, it's typically stored in /var/lib/docker/volume something. We'll take a look at that. But you don't need to care about that path. Docker handles it. You just need to care about the named volume. Think of it like this. Docker gives you a managed hard drive. The key benefits: this survives container deletion, it's easy to reuse across several containers, and it's more portable than bind mounts. You would typically use a named volume when you're running databases, when you're running production workloads, or anything stateful really. Let's take a quick look at another example. Let's move over to the terminal. Boom. And then we're going to take a look at the Docker Compose file I wrote. It's just very simple. Service Postgres, specifying the same image to use. We're defining a username, password, and a database name. And right here, we're telling Docker that we need a named volume called Postgres_data. And inside the container, we tell Docker that we're going to use this named volume at this specific path inside the container. So we're using Postgres data in varlib PostgreSQL. If you're using Postgres 17 or below, you have to change this to /data after varlib Postgres, like that. So what happens now? We can run docker compose up -d, and it starts. We can just run docker compose logs -f to verify database system is ready to accept connections, and then we can run docker compose exec postgres psql -u ubuntu, and then we're inside PostgreSQL. So I also prepared some very simple SQL statements right here. It just creates a table, insert some sample data, and select to show the data. I'm just gonna copy this, and then I'm gonna go back to PSQL shell. I'm gonna paste in this. So now we created the table. You can say Postgres created a table, and we inserted 3 entries. And now we just select from users. Boom, and we see we have the data. So what we're going to do now is we're going to run docker compose down, and then we see that the container is completely removed. But since we're using a named volume, the data is still persisted on disk. So if we do sudo ls varlib docker volumes, you can see that we have lots of stuff I worked on, but we have this PSQL Postgres data. So we're going to do this. Let me see, we have the dash data right here, and inside there we have another folder 18, and inside there again we have Docker, and here we have the actual PostgreSQL data. We have the Postgres configuration, so we can check out this PostgresConf. See, here we have all the Postgres configuration files, and if we do sudo find inside here, you can see that we have all the PostgreSQL data persisted on disk here as well. So if we now run docker compose up -d and docker compose exec, and then we run the same select statement, select star from users, we can see that the data persisted through a removal of the container. So that's pretty nice. So the simple rule is to use bind mounts for development environments and use named volumes for production. Of course, there will be some variations where you want to use bind mounts for production and you want to use named volumes in development. But as a general guideline, I would suggest that you use named volumes in production and bind mounts for development environments. So I also told you about the third option, which is tmpfs. It's a bit different. With tmpfs, you store data on RAM instead, so you have no persistence, but you have super fast and completely temporary disk straight inside the container. But this one is deleted when the container stops as well. It's very good for temporary caches, sensitive data that needs to never touch the disk, and high performance workloads. I'll show you how it works. But first, let's just bring down the container. So we're just going to run the nginx container again. Right here, and then we're gonna add another option, tmpfs. We could also use docker run -help, and then we can see tmpfs list mounts a tmpfs directory. So when we now do docker run rm boom, and then we add --tmpfs user. So we now run docker compose with tmpfs. Boom, we have the nginx running with tmpfs. Even for more simplicity, we can run tmpfs on /temp. So now we have RAM disk mounted inside /temp in the nginx container, where data never persists on disks, and it's super fast because it lives inside the memory. Okay, so to wrap things up, the writable layer in Docker is a scratchpad. Everything gets deleted when you stop the container. A bind mount is a local file or directory on your local machine mounted directly inside the Docker container. A named volume is Docker's managed storage. And tmpfs is RAM, fast but temporary. So the key takeaway, containers don't persist data by default. If you care about your data, use volumes or use bind mounts. Otherwise, it's gone. If this helps, drop a like and subscribe for more Docker and DevOps deep dives. See you in the next one.